Mr. Sweeting, what have you learned so far about Estonia and our technology sector?
Well, firstly about Estonia, it is my first visit. So it's been really delightful to have a look at the old city and to see the developments in the new city, and also to meet people and to get a feeling for the hospitality and have a very interesting technical as well as cultural discussions. On the technology, obviously this is a short visit, so I have not had a chance to have an in-depth view, but I can see clearly in the in the area of information technology and the potential for applications to space. This is clearly a strength of the country, and I think that there are some opportunities in space which companies in Estonia and academia, universities can participate.
Surrey is a satellite company, and I know that in 2008 you have done a proposal for Enterprise Estonia. Can you describe this proposal?
Well, in general, what we said was that we have had a long history of working with international partners in many countries, and we felt that it would be a good idea to perhaps Estonia and UK through Surrey to work together, and in this way develop small satellite activities in Estonia to be the catalyst or the kernel for larger space activities to develop in over the next 10 years or so. And so to have an activity which is going to involve exchanges of people, focusing on development of a small satellite which would be tailored to Estonian needs. And this was the idea, to do this, to generate both the technological knowledge, but also to involve the people directly in space, but at a scale and at a cost which is sensible for a small country.
Why would Estonia need its own satellite, and isn't it too expensive for a very small country?
Well, small satellites have a small cost, and that is ideally suited to small countries. The reason for actually any country to be involved in space, whether they are a large country or indeed a small country, and the UK is also small, is because space gives a high vantage point. You're looking down on the Earth from a high point, and this is good from the point of view of Earth observation, for climate change, for pollution, for agriculture, water use, natural hazards. It also provides eventually a position from which you can carry out communications and navigation services. I think Earth observation for small countries is becoming particularly important because many of the problems that we face are not limited by national borders. So we are interested not just in what happens in our own country, but what is happening increasingly around it in our neighbours, and also more globally. And that allows each country to manage their own unique resources in a more effective manner.
When we talk about satellites, we talk about the future services. What's your understanding of the future services? So what sort of services are we going to use?
Well, if I knew the answer to that, I would first of all keep quiet, and secondly become rich later. But in general, I think we will see Earth observation becoming, from space, becoming more embedded in the day-to-day usages. We already see this with things like Google Map and Google Earth, where Earth observation data and mobile phone services and digital information services combine to provide something really useful to the user, and the user doesn't really appreciate that it is based largely on space information. So I think we will see developments of that, extensions of that type of service for increasingly down-to-earth applications. Now, if I knew exactly what they were, as I say, then I would keep quiet. But it's clear, combined navigation, Earth observation, communications from space, together with terrestrial space distribution and digital information systems. I think we will see that combination coming together to spin up many different applications. In just the same way that we didn't expect the tremendous growth of navigation services in domestic cars when GPS was first launched, and now this is an enormous industry. These things take time. New ideas will come up, but they will take some years to develop and really mature.
You have made an interesting point by saying that the satellite infrastructure will be as a good alternative for land infrastructure, which is expensive. Can you elaborate on this idea a bit more?
Well, I think space infrastructure in many ways augments land infrastructure and sometimes surpasses it. For example, it's very flexible. If you put in a lot of fiber or copper on the ground, you want to change it because the technology at either end changes, then you have an enormous amount of work to do to replace that infrastructure. Whereas with space, you can either reconfigure the spacecraft almost instantly, or at the least you can launch a new satellite with this new technology, and then you completely cover the whole area in one go. Secondly, one of the advantages of satellites is they run on sunlight. And therefore it is essentially a green power source in as much as it's non-polluting. So as the spacecraft get higher power, as we require larger amounts of power to distribute our, shall we call it, internet services and all the so forth, then if we transfer that into space, we can transform sunlight into electrical power, into services, without the pollution that goes along with ground-based systems. So it's flexible. It's green, and also, of course, you can reach very remote regions, mountainous regions, for example, where it's difficult to provide a very comprehensive infrastructure, and the communities living in those regions might be disadvantaged.
But what are the main technological obstacles in using satellites?
I don't think there's much in the way of obstacles in using the satellites. The biggest single obstacle to making more use of space is the cost of getting things into space, the cost of launches, rockets. And whilst there are industrial companies trying to reduce that cost, they are reducing it a little bit. What we need to do is reduce it dramatically. So rather like the approach we took to satellites, which has reduced the cost almost by a factor of 10 for correspondingly complex satellites, we need to do the same for rockets, otherwise it doesn't make sense. So at the moment, the biggest obstacle to really developing space is the cost of launch. The cost of using it once it's up there and the complexities of using it actually are not the major hurdle. Those will develop because many of the same applications are required on Earth.